Hello distinguished viewers, welcome to Simplified Math Class again. Simplified Math Class, it has always been. And today we are going straight to the topic, polygons. Alright, but please, before we proceed, I would love you to subscribe to this video and then you click on the bell notification. God bless you as you do that. Without much ado, we go straight to the polygons. A polygon is an enclosed figure bounded by straight lines. That's what a polygon is. And a polygon is said to be regular if all the sides of the polygon are equal. So a regular polygon is also known as a polygon that is equiangular. All right, please take note. It means it also has internal angles that are equal. That's what a regular polygon is. Since it has all the sides equal, the internal angles are also equal. And then we have what we call a convex polygon. A convex polygon is a polygon that has all its interior angles less than 180 degrees. Please take note of that. Then we also have what we call a reentrant polygon. A reentrant polygon is a polygon that has one of its interior angle greater than 180 but less than 360 degrees. That's what a reentrant polygon is. As we proceed, we'll solve problems that involve these types of polygon. Alright, so for a regular polygon, the following are the types of regular polygon. Alright, so we have regular polygon, and then we have number of sides the polygon has. Alright, so we have equilateral triangle, This is a regular polygon that has 3 sides. Then we have a square, a regular polygon that has 4 sides. So we have a pentagon, a regular polygon that has 5 sides, a hexagon, a regular polygon that has 6 sides, a heptagon, a regular polygon that has 7 sides, an octagon, a regular polygon that has 8 sides, a nonagon, a polygon with 9 sides, and then a decagon, polygon with 10 sides, a non-decagon, and the rest. So we have them so many. But these ones, you will always hear them. The names will be mentioned in the course of you solving problems. But anything above 10, they will just tell you a polygon with 12 sides, or a polygon with 15 sides, a polygon with 20 sides. But when it comes to this, they'll just mention an octagon. They won't tell you the number of sides. It's heptagon. They won't tell you the number of sides. So take note of these basic types of polygons. Alright, so without wasting time, we'll be going straight to solving problems that involves polygons. Alright, so we have what we call the interior angles of a polygon. Now note that the sum of the interior angles of a polygon is given as, when you want to find the sum of the interior angles of a polygon, sum of interior INT angles has a formula. When we want to find the sum of the interior angles of a polygon, you simply have to do this: n minus 2 multiplied by 180, where n is the number of sides that polygon has. You can equally use this other formula, 2n minus 4 right angle. 2n minus 4 right angle. You can also use this formula, you still have the same thing. But we'll be concentrating on using just one formula so that we don't get confused, the first one. Alright, so if the sum of the interior angles of a polygon is this, therefore it means that if the polygon is regular, each of the interior angles of that polygon will be n minus 2 times 80 divided by n. That will be each interior angle of that polygon. Please take notes. This two key formulae, very important in solving problems. So we take them as two key formulae. All right, so also the sum of the exterior angles of a polygon, the sum of the exterior angles of any polygon is equal to 360 degrees. Please take note of that. It therefore means that if the polygon is regular, each exterior angle will give us 360 degrees divided by n if the polygon is regular. So we are going to go straight to solving problems that involves this. Number one. All right, they can say, for instance, find the interior angle of a regular octagon. Number one, find the sum of the interior angles of a regular octagon. So we want to find the sum of the interior angles of a regular octagon. All right, so take note that an octagon, a regular octagon has 8 sides that are equal. The whole 8 sides are equal. That's why it is a regular octagon. So the sum of interior angles, we have said, has a formula which is n minus 2 times 180. All right, where our n now is equals to 8 because the polygon has 8 sides. It therefore means that we are going to have 8 being n minus 2 multiplied by 180. 8 minus 2 is 6. 6 times 180 will give us the sum of the interior angles. 6 times 180. All right, so it means each interior angle, it therefore means that the sum of interior angles will give us 108 degrees. Note of that. Now, since the polygon is regular, it therefore means that each interior angle, because it should be each interior angle, therefore each interior angle will be, for you to divide that 180 degrees by the number of sides the polygon has. That is 180 degrees by n is 8. 180 divided by 8, you have 135. It therefore means that each of the interior angles of that regular octagon will be 135 degrees. Please take note, if you have a polygon like this, okay, so take this. All right, now this is an example of an octagon. Now what we mean is that if this octagon is regular, each of these angle is 135 degrees. Each of this angle is 135 degrees. Each of this is 135 degrees. Each of this is 135 degrees. This one 135 degrees. This one 135 degrees. This one 135 degrees. And this 135 degrees. So that is an example of a regular octagon. We have done that. So it means if we sum the whole of these interior angles, you have 1080 degrees. Please take note of that. Now, sometimes they will ask you to find each of the exterior angle. This is what we call the exterior angle. If you extend this line, this is an exterior angle X. All right, if you extend it anywhere, even if you extend this line, this will be another exterior angle X. Now that exterior angle X, of course, will be 135 degrees plus X degree, giving you 180 because they fall on a straight line. So it will be 180 minus 135 degrees. Please take note of that. So assuming we are asked to find each exterior angle, each exterior angle will be, of course, 360 divided by n, as we have seen. So that will be 360 degrees divided by n is 8. It therefore means that each exterior angle will give us 45 degrees. Please take note of that for this regular octagon. It therefore means that every interior angle plus exterior angle must give 180 degrees. Please take note of that. So the interior angle is 135 degrees plus the exterior angle we just calculated, 45 degrees. So if you sum those two, you have 180 degrees, which is the angle on a straight line. Because if you watch this line, you notice that it's a straight line. The interior angle plus the exterior angle must give you the sum of the angles on a straight line, which is 180 degrees. Alright? So when you're asked to find the sum of the interior angles, this is what you do. Each interior angle is to divide by n, and then each interior angle of a polygon is 360 divided by n, because the sum of all the exterior angles of a polygon gives 360 degrees. So which means that if you take this n, the outside one, the x, which is the exterior angle, x exterior angle into 8 places, you sum them, you should have 360 degrees. So therefore 45 degrees times 8 give us 360 as it is. Please take note of that. Alright, we are through with it. Let's take another example. Alright, one of the interior angles of a hexagon, let's say one of the interior angles of a convex hexagon is 170 degrees. One of the interior angles of a convex hexagon. Number 2. One of the interior angles of a convex hexagon is 170 degrees. One of the interior angles of a convex hexagon is 170 degrees. Now they say we should find each of the remaining angles. Alright, it therefore means that a hexagon, of course we know, has sides. It is convex because one of the angles is less than 180 degrees, because a convex polygon is a polygon whose interior angles are less than 180, and that's have 170 degrees. It means that it is a convex polygon. I want to find the sum of each of the remaining other angles. Definitely one will be up to 180 degrees because the polygon is convex, and I know that the convex polygon is a polygon that has all its interior angles less than 180. Alright, so what we need to do first is to find the sum of its interior angles. Sum of its interior angles, which is n minus 2 times 180. N is 6. 6 minus 2 times 180. 6 minus 2 is 4. 4 times 180. Alright, so that will be 720 degrees. 4 times 180. Alright, so we have 720 degrees. It therefore means that the sum of all the angles of a hexagon will give 720 degrees. Now, since one angle has been given, we are asked to find the other. Alright, the one angle given is 170 degrees. The rest are all equal. They say find each of the remaining angles, meaning that each of the other remaining angles are equal. So the second angle is x degree, the next angle is x degree, the next is x degree, the next is x degree, and the last is x degree. A hexagon has 6 sides and 6 angles. 1, 2, 3, 4, 5, 6 angles. So the sum of all this should give us the 720 degrees we just computed. Alright, so we are going to have 170 degrees plus x plus x plus x plus x plus x will give us 5x degree. That will be equals to 720. So we are looking for 5x degree. That will be 720. 170 crosses to be minus 170. Alright, 720 minus 170 will give us 550. 5x degree will give us 550 degrees. X degree will be 550 divided by 5. And that gives 550, 110 divided by 5, 110. 110 degrees. You see, 110 degrees. You see what I was telling you? For a polygon that is convex, none of the angles will be up to 180. The one they've given 170, the remaining are still 110. So none will be up to 180. Therefore, each of the remaining angles equals 110 degrees. Please take note of that. All right, we are done with this slide. When next we'll be meeting, we'll be taking complicated problems that have to do with polygons. But no matter how complicated they are, it will always be easy for you to solve, because you know what the sum of the angles of a polygon are, each interior angles what it should be, what the sum of the exterior angles are, and what each exterior angle will be. So it will be very easy for you to analyze them out. We'll be solving this problem in the part 2 of polygons. No matter how complex they seem to be, we'll bisect them to what they ought to be. Thank you for watching this slide, and please let me also remind you to please subscribe to our channel by clicking on the subscription notification and then the bell notification. And if you have any question to ask, please on the comment section, please give your question there and we'll respond to your comments. And if you enjoy the slide, please give it a thumbnail. All right, God bless you as you do that. See you in the next slide, Polygon part 2. Cheers.